In this lesson, we'll discuss backing up data. Backing up your data is absolutely critical. It must be done consistently and strategically. You need to know 3 different types of backups. The first is the full backup, the second is the incremental backup, and the last is the differential backup. Let's explore the different types of backups. Let's first discuss a full backup. A full backup backs up everything. It doesn't matter whether archive bit is set or not on any file. However, as it backs up each file, it clears the archive bit to indicate that the file is backing up. In this way, you can determine if a file has been modified at a later point in time. If you were to modify a file that has been backed up, the archive bit would be reset, indicating to the backup software that this file has been modified since the last time it was backed up. If a file is not modified after the full backup, the archive bit is left in a cleared state. This is important because other types of backup, such as incremental, take into consideration if this archive bit has been cleared when deciding whether it should back up a file or not. An incremental backup will back up everything since the last full backup, or since the last incremental backup. To determine whether or not a file has been modified since the last full or incremental backup, it looks at the archive bit. If the archive bit is turned on, that tells the backup software that the file has been modified since the last full or incremental backup and needs to be backed up again. Once it's backed up the file, the archive bit is cleared. Let's run through an example. Suppose you perform a full backup of the entire file system on Monday. As a result, every file in the file system has been backed up, and the archive bit on each file is cleared. Then, on Tuesday, you perform an incremental backup. Because the incremental backup only backs up files with the archive bit set. It will only back up files that have changed since Monday. Accordingly, the incremental backup you made on Tuesday will be relatively small because it will only contain 1 day's worth of changes. After backing up the changed file, the incremental backup will clear the archive bit again on the files that were backed up. If you perform another incremental backup on Wednesday, it will once again look for any files with enabled archive bits, indicating that they've been modified since either the last full backup on Monday or since the last incremental backup on Tuesday. Therefore, Wednesday's incremental backup also only contains 1 day's worth of changes. Likewise, if you run another incremental backup on Thursday, then only the changes that have been made since Wednesday will be backed up. The same is true on Friday. The advantage of this strategy is that the daily incremental backups finish relatively quickly because we're only backing up 1 day's worth of changes. The full backup still takes some time to complete because all files are being backed up. For this reason, the full backup is usually executed over the weekend when the system is not heavily used. The incremental backups can occur each weekday because they don't take much time to complete. They typically don't interfere with day-to-day work. Incremental backups have one significant drawback. The incremental backup strategy is the slowest type of backup for restoring data. For example, suppose we ran a full backup on Monday and then ran an incremental on Tuesday, Wednesday, Thursday, and Friday. Then the server crashes on Saturday, and we need to restore all the data back to the server after we've recovered from the crash. The first thing that you must do is to restore the first full backup from Monday. Then you must restore every incremental backup in the order that they were created. First, you must restore Monday's incremental backup, followed by Tuesday's backup, then Wednesday's, Thursday's, and Friday's backup. Each backup must be restored in the proper sequence to return the system to where it was before the crash. This can take hours or even days to complete, depending on how much data is involved. Another option is to use differential backups instead of incremental. A differential backup looks for files that have been modified since the last full backup. It does this by evaluating if the archive bit has been set on the files. If the archive bit is clear, it will not back up the files because it assumes that it has not been changed since the last full backup. If the archive bit is set, the differential backup assumes the file has been modified and needs to be backed up. The key difference is that a differential backup does not clear the archive bit after backing up a file. Therefore, it backs up everything modified since the last full backup, but not since the last differential backup. This has advantages and disadvantages. Suppose you perform a full backup on Monday, just as with the incremental backup strategy. This clears all archive bits on all files. Then we perform a differential backup on Tuesday and Wednesday. Because the differential backup on Tuesday does not clear any archive bits, Wednesday's differential backs up all the files that have been modified since Monday. Thursday's differential backup includes all the changes made on Monday, Tuesday, and Wednesday. Friday's differential backup includes all the changes made on Monday, Tuesday, Wednesday, and Thursday. As you progress through the backup schedule, each differential backup takes progressively longer because it's backing up more data each time. The first differential backup completes in the same amount of time as an incremental would because we're only backing up 1 day's worth of data. However, each subsequent differential takes longer. The advantage of differential backups is the speed of restoring data. With differentials, all we do is restore the full backup, followed by the last differential backup. For example, if a server were to crash on Saturday, we would restore the full backup from Monday and then the last differential backup from Friday. That's all we do because the last differential backup contains a backup of every single file that has been changed since the last full backup. You should never mix differential and incremental backups together with a full backup. If you mix full backups with incremental and differential backups, you're going to have problems because of the way these different types of backups handle the archive bit. As a result, files that should have been backed up will be missed. Another alternative for backing up data is to create a system image. Imaging programs create a bit-level mirror of a particular hard disk or partition. Newer versions of Windows and all versions of Linux include this functionality. Typically, a system image is created on a defined schedule. Because a system image backs up the entire hard disk or partition, they are rather slow to create. However, they are very fast to restore. All you do is restore the image to the same hardware or even to a new piece of hardware if you have a major hardware malfunction. And the system is back and available again in exactly the state it was when the image was created. This can be very useful in the event of a malware infection. Most of the time, it's easier to re-image a machine that's been infected with malware rather than try to get rid of the malware. There are other types of data to back up. For example, if you're managing a domain controller in a Windows network, then you need to back up not only the files on the server, but all your Active Directory information as well. To do this, you can create a special type of backup on the domain controller called System State Backup. If you are backing up sensitive information, such as security logs, then you might want to consider the location of the backup, instead of backing that data up to a device that can be modified in some way. Find a more secure option. That's it for this lesson.